Hello, my name is Hans George Campbell. Welcome to part 2 of my IBM PC 5150 restoration videos. This is part 2. In today's video, I'm going to use a brush and alcohol to clean this area of the board. I don't think it needs anything more than that. I think the board's fine. I'm going to push down on the chips, reseat the socket of the chips. It's best to do that when the board is laying flat on your anti-static mat. And then I'm going to unsolder. There's 11 tantalum capacitors that need to be removed from the board. And then we're going to solder on, there's 11 of them, 11 tantalum capacitors that need to be removed. And we're going to replace them with 11 brand new ones. So yeah, and I thought I'd do that underneath the camera because a lot of you mentioned, like in my Commodore 64 recapping video, some of you mentioned that although you liked the video, you wanted to see me actually desoldering the capacitors and solder on the new ones. You wanted to see how I do it. And so in this restoration video of my IBM PC, I thought I'd do that for you guys. So that's what we're doing today. All right, here is the SAMS ComputerFacts technical service data for the IBM PC 5150 computer. So we're going to scroll down to the page that we need to see what the value of the capacitors are. The C7 capacitors, which is right here. And let's go to that page view there. Well, shoot, when I go there, it won't let me. Okay, I'll have to do it this way. Anyway, this is for, as we can see on the bottom of the page, it says system board. Got to make sure, because this also talks about the other boards as well, and they also have C7 capacitors on them that are different value. Okay, so make sure that when you're looking at this SAMS documentation here, that you make sure you're on the system board page, which is page 5. And the capacitors that we are concerned about, because see where it says here, printer adapter board, okay, there's a C7 there. Okay, but anyway, let's look at this board. Disk drive board, if you notice, C7 on this board is 0.047 microfarad. So that's what I'm talking about. You have to be careful that you're looking at the actual motherboard itself, which is going to be up here. Okay, on the 12 volt line, there's on the 64K to 256K motherboard, there is only one C7 capacitor on the 12 volt line. And all of these C7s appear to be 10 microfarad, and they're 16 volts. 10 microfarad to 16 volt. On the 5 volt line, we're only concerned about the C7 capacitors. These are the only ones that you need to replace. Okay? So it looks like we've got, what, 1, 2, 3, 4, 5, 6 of them on the 5 volt rail. Okay. Now I don't know if this is silk screened on the motherboard itself. I don't think it is. But so basically we have 7 C7 capacitors that need to be replaced. And they're all 10 microfarad, 16 volt. Now we also have some C7s down here. Looks like there's 4 of them here. Okay, they too are 10 microfarad, 16 volt. They're part of the 5 volt line. Okay, so that's 10 C7 capacitors on the 5 volt line. All right, and 1 on the 12 volt line. And this is coming directly from the schematics. Okay, this way there's no arguments as to what value to use, and yeah, and how many capacitors there are that need to be replaced. 1 C7 on the 12 volt line, that's near where the power connector is. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 C7 capacitors, which are 10 microfarad, 16 volt, on the 5 volt line. All right. All right. After removing the 3-lead tantalum capacitors, I'm going to replace them with normal 2-lead electrolytic capacitors. And the way you do that is, well, we'll zoom in on this part right here. Well, let me zoom in on this part. Let me move the caps over. Maybe you can see this a little bit better. Maybe zoom in a little bit more. Maybe you can read it. Yeah, read that page or whatever, right? All right. This is your normal 3-lead tantalum capacitor. That's what's in the board now. Okay, well, I'm going to unsolder those capacitors, and I'm going to solder in normal 2-lead electrolytics. And they can be soldered in either way. Okay, the positive is in the center, but I'll double check that on the board when we get ready to do that. And then on either side of that center is your negative. So the electrolytic capacitor can go on either way, just as long as you have the positive lead in the center there. Okay? So I just thought I'd show you this. And then the capacitors that I'm going to replace them with are these capacitors here. These are very high quality capacitors. I believe these were made in the United States by Sprague, which is an old German company. But these are really good capacitors, these right here. Now there's one C7, they're all labeled C7. There's one C7 on the 12 volt line. According to the SAMS schematics, all of the capacitors are, let me zoom out a little bit. All of the capacitors are 10 microfarad, 16 volt, but what I would recommend doing, being an engineer's assistant and a technician, I would replace, you know, the 10 microfarad, 16 volt, go with the same value, that's fine, for the 5 volt line. I believe there's, what, 10 of them on the 5 volt line? And then the one that's on the 12 volt line, okay, I would go with 10 microfarad, 25 volts to be on the safe side. when you're dealing with this old equipment. Okay, so that your voltage on the capacitor, your voltage rate on the capacitor is double the voltage coming out of the power supply. So on your 5-volt rail, 16 volts would be fine, 10 microfarad, 16 volt. And then on the 12-volt line, there's only one of them. I would go with a 25-volt, 10 microfarad capacitor. Okay? We're going to need a soldering tip like this one, about that size. I think this is a 1.2 millimeter, but that's the size that you're going to need. Okay, and you're going to need that solder. If you use this high quality Kester solder like that, you do not have to use flux. In fact, as soon as I see you guys using flux on your YouTube video, I can't help but think amateur that does not know what the hell they're doing. You do not need to apply flux before soldering. If you are using a high quality solder like this Kester solder right here, this is the exact same solder that I use professionally in the electronics industry. Okay? And that's the solder that I recommend that you use. I'll zoom in a little bit further so you can read what's on the label, so you can order it for yourself. This is a 1-pound spool. It'll probably last you the rest of your life. You know, it just depends how much soldering you do. But you don't need to use flux because this is rosin core solder. So it basically has flux inside the solder. The solder is like hollow on the inside, and it contains rosin or flux, which cleans the board as you're soldering. So liquid flux is not needed and is not required. In fact, when I did soldering in the electronics industry, because I worked in the electronics industry for 25 years as a technician, an engineer's assistant, and a mechanical and electronics assembler, we almost never used flux when we soldered parts onto the board. Whenever we had to hand solder parts onto the board, we never used flux. Ever. This is coming from a professional. Okay, so don't do it. Just get yourself a high quality solder like this. This is exactly what we used in the industry before we switched over to that water soluble garbage that we use today. Okay, this is really good solder. Okay, you also want to use 99% isopropyl alcohol for cleaning the board, and you want to use a brush. Well, let me get the solder out of the way. You want to use a brush like this. Do not use a toothbrush. That's another thing that I see so many of you people using in your YouTube videos. Don't do it. Use a brush like this. This is the type of brush we use professionally in the electronics industry whenever we had to clean boards. Okay? Now, usually when you buy these, the bristles are about that long, so you'll have to cut them down to however short you need them. I have mine at about, I don't know, 3/8 of an inch. That seems to be a good size for general cleaning of PCBs. And you can get these like at Ace Hardware. They sell them. You can get them at your automotive supply stores because a lot of automotive mechanics, they use these for cleaning parts and stuff. So yeah, or you can get them on eBay or whatever. But this is the correct brush to use for cleaning circuit boards. Do not use alcohol in a sprayer. I see so many of you dumbass using, you spritz on the alcohol with some sprayer. Don't do that. I will teach you the correct way to clean the boards. Do not use a toothbrush like I see so many of you dumbasses using. Don't do it. This is the correct brush to use right here. Okay? That's the brush to use. Okay, so when I get back, I'll unsolder the old capacitors and we'll solder on the new ones, you know. And a lot of people keep talking about huge ground planes. I call bullshit on that. I really do. I call bullshit on that. This board does not have huge ground planes. Okay, and it's really easy to unsolder the parts. I don't have any problems at all desoldering any of the parts on this board. No problem at all. So if you do, there's something you're doing wrong. You're either using the wrong size tip, or you're using the wrong temperature, either too cold or too hot. And yes, there is such a thing as being too hot. Or you're using a crappy soldering system like a Heiko. Heiko is crap. Okay, I'll tell you that now as a professional. Heiko is crap. It's garbage. I bought one brand new. I put it away. I put it away because it's garbage. I went back to using my old Solderate OK soldering system, which is one of the best soldering systems you can get. And the only other system I would use a Weller soldering iron. They make the best. Or, like for surface mount parts, I'd use Metcal. Either a Metcal soldering system or a Weller soldering system. If you have that Hacko shit, yes, shit, throw that away. Throw it away or sell it on eBay or Amazon. Get rid of it. It's a piece of junk. Okay? You want to either get yourself a good quality Weller iron, or if you can find one of these Solderate OK irons, I'll highly recommend these. And these are the irons that we use professionally in the electronics industry. Now, I'm telling you what we used. We did not use Heiko at all. We just never used them. We used the Solderate OK irons, we used the Weller irons, and we used for surface mount, we used Metcal. And I'm sure those of you that have also worked in the electronics assembly or electronics manufacturing, you are familiar with the Metcal irons. They're really good quality irons for surface mount. But yeah, when I get back, we're going to start removing these old tantalums. And after that, we're going to solder on these new, brand new high quality, normal electrolytic capacitors. I do not recommend going back with tantalums. The reason for that is because when tantalums fail, when these actually usually don't fail, they just start leaking after 20 or 30 years for the good quality capacitors like these. You don't have to worry about these for at least 20, 30 years before they start bulging or leaking or whatever. These are really good quality capacitors. Okay? But the tantalums, when they go bad, they can short out. A direct short. They can apply a direct short to the system, which can do major damage not only to the motherboard, but especially to your power supply. Now, most power supplies, they have short circuit protection, overload protection, and things like that. But that's with the more modern power supply. I don't know how they have the older power supplies done, because I haven't really looked inside one yet. But I will be looking inside these IBM power supplies that I have in the near future videos, because I need to recap them, refurbish them, put in new fans or whatever. So we'll take a look at them and see what kind of protection circuitry that they have inside in near future videos. Anyway, let's go with the recapping of this motherboard. Alright, before I get started, I wanted to show you some more tools that I will be using today. If you don't have one of these right here, I highly recommend that you get one to go with your 1 pound of high quality Kester rosin core solder. This is a really nice unit. You can pull your solder through here like that. It's got a carry handle. You can carry your solder around. Heavy die cast. This is heavy steel. Really well made system. And I highly recommend this for your solder. I highly recommend one of these. That's what I use, and we actually use them in the industry too. For your alcohol, instead of getting that spray bottle that a lot of you people like to use, get one of these right here. It has, you open this up right here and you push it. It has like a built-in pump. It pumps the alcohol up to the top there. Then you can dip your brush in like this. This is what we use professionally. I'm showing you the professional way of doing it. Or your cotton swabs, your cotton makeup pads, you know. This is what we use professionally. Let me get one that's not filled with alcohol. Yeah, I don't think this one's filled with alcohol, but yeah. I think they're like, I don't know, $5 or $6 on eBay, you know, and you can label them any way you want. These are also great for, like, if you wanted to put like white distilled vinegar in these for like to neutralize battery alkaline leakage. It's not really an acid. When you're talking about batteries, it's not an acid, it's an alkaline. So for battery alkaline leakage, okay, you want to use an acid to neutralize it. Basically, white distilled vinegar. And you can put it in here, make sure you label it, white distilled vinegar, so you don't get it mixed up with your alcohol bottle, you know. But yeah, that's what I would use for that. And then for capacitor leakage, now that is an acid, okay. To neutralize capacitor leakage, you want to go with a baking soda, a base. What you're trying to do is you're neutralizing the pH to 0. That's where you want it, okay. Acid is from 0 to 7. Excuse me. That's a base. 0 to 7 is a base, and acid, I believe, is 0 to -7, which is an acid. Okay, and so what you're trying to do when you use like baking soda on acid, you're trying to get it back up to 0. And the same thing with alkaline, battery leakage, okay, which is alkaline, okay, and you apply the vinegar, that's to get that back up to 0. And that's basically what you're doing to neutralize that you know, the leakage, either alkaline leakage or acid leakage. Okay, the other thing I recommend doing, instead of using the electric desoldering gun that I see a lot of you use, and I've used them in the industry too, but to be honest with you, I recommend a big blue like this one. Let me zoom out just a little bit more. I recommend a big blue, just a hand desoldering pump like this. Do not use the small ones. You want a big one like this. Creates a lot of suction in here. It's got a very powerful spring right there. Okay, with a stainless steel rod right there to make sure this stays straight. And it goes up and down evenly. These are really good. And one of the reasons why I recommend these is because, okay, when you're using a desoldering gun, the tip is made out of metal, and you have to really, you know, go on the circuit board like this. You know, you take a chance. There's a high risk factor of that metal tip damaging the pads of the board. Whereas a hand desoldering pump like this has a heat-resistant plastic tip, which it doesn't mess with the board as much. There's less chance of this type of tip here messing up the pads or lifting the pads on your board. Because I've noticed a lot of you, when you're using those metal-tipped electric desoldering guns, you know, or workstations, you actually have ruined a lot of the pads, and you don't even realize it. But I've noticed it when I'm watching the videos. So I highly recommend you don't use that. Go to using, use one of these. Specifically, this one. This is what we use in the electronics industry. One just like this. These cost about $8 on eBay. Okay, and they're really good. This is what I'm going to be using today. And this is the package that it comes in. I keep a spare. I use these so much that I have a spare hanging up on my workbench pegboard behind me. I have more tools behind me. But this is what the packaging looks like. Okay, and this is what I recommend that you use, is one just like this. Okay, I recommend this. I mean, this is what I use professionally, right here. And like I said, the heat-resistant plastic tip, there's less of a chance of this tip messing up the pads on your board. Okay? Because with this type of a tip, you're not going like this, and you're putting pressure with that metal tip on that board. Now, with this one here, you heat up the pad, and you put this down, shoop, suck that shit right up. I'm actually faster with one of these than I am with an electric desoldering gun, which in my professional opinion are for lazy people. Lazy, stupid dumbasses. Those are the type of people that use an electric desoldering gun. Because believe it or not, in the 25 years I worked in the electronics industry, we rarely ever used an electronic desoldering gun for desoldering parts. We actually use a big blue just like this. A hand desoldering pump just like this. This is what we use professionally, and it works very well. And the main reason why we use these instead of the electronics desoldering gun, right, is because this has a plastic tip, not a metal one. So it's less likely to damage the boards. Because you have to understand, some of the boards I worked on, they cost thousands of dollars per board. Okay, so yeah, they don't want the pads being damaged or whatever on the rework. Anyway, the soldering iron should be heated up by now. I turned it on before I started this part right here, so it should be nice and hot, ready to go. So I'll be back after a quick break. One other thing I forgot to show you guys. These are the magnifying goggles that I use. These are 7-power. And these are the older ones that use glass optics. The newer ones that use plastic optics. I don't recommend these. These are glass. And you can change these out. Like this is a 7-power magnification. You can get them starting at 2-power all the way up to about 20 power. But 7-power seems to be what works best for me. And this is what I use when I do my work. Especially when I'm doing, like desoldering. I like to use these, or soldering. I like to use these. And these older ones, I'm just blowing off the dust. They have an adjustable thing in the back here, so it fits your head. It has like a comfortable padding right here. It's got foam on the inside of this. So they're real comfortable. And then you can see on the inside where there's like a nut right there and a bolt that goes through, and then this slides out. But you can change these lenses, and these are glass optics. It has a plastic frame, but the lenses themselves are made out of glass. They're glass optics. And these are really nice. It's called an Optivisor, made in the USA. I recommend getting a vintage set like this. You can see how it's made. It's very high quality. And I've had these, oh man, about 30 years probably, at least 30 years. And they're still in really good shape. You can adjust how tight they are, how loose the visor is with these. And they're just very nice. But this is what I'm going to be using today. So you'll probably see these underneath the camera on my head. So this is what they are, in case you're wondering. This is what I'm going to be using today. All right, let's get the recapping. So, the first capacitor I'm going to remove is this one here on the 12-volt line. That's the only one. Definitely these three on the 5-volt line. So that's, let's count them. Okay, let's count them. Let me get my pointer. So it looks like we got, that's the one on the 12-volt line. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, there's one there too. Yeah, one of these may not need to be replaced. I have to see, because there's only 10 of them on the 5-volt line that need to be replaced. So definitely these three here for sure, and that one there on the 12-volt line, definitely. But I'm also thinking these here sometimes will short out too. So yeah. All right, soldering iron. Let me go ahead and tin that baby. Let me put the solder over here. I'm going to need to tin this a little bit. Yeah, I'm going to need to tin it. Alright. So, yeah, that's like that. Okay. So what we're going to do now, I don't think I'm going to have to put fresh solder on that. The solder on it looks pretty good, but I think I'm going to have to turn it this way. Let me get these capacitors out of the way. I'm going to have to turn it this way. Let me make sure it's still underneath the camera, because of the way these leads are. They're going this way, and your solder pads are on each side. So what I'm going to have to do is to, okay, all right, okay. Huh. Okay, I might have to apply some solder, fresh solder on there to get that to work properly. Now, if there's a ground plane in here, it's going to be on an internal layer. It's not going to be on an external one, I mean on top or bottom, because I don't see any huge ground planes top and bottom. So if there is a huge ground plane like I hear so many of you talk about, it's got to be on the inside. It's got to be on an inner layer. You know what? I might have to do this a different way. There might be a huge ground plane on there. Let me see something. What I may have to do, let me get my cutters, okay, and then I'm going to try to do this underneath the camera so you guys can see what I'm doing. But what I'm going to have to do, shit, this is like, this body is all the way down to the board. Okay, I cut the one lead, and I'm going to try to rock it out of there. And it'll be easier to suck the solder out once I have the lead, once I have the leads removed, you know, from the board. So that's what I'm going to do. Okay. Damn it, it keeps wanting to slip off of there. Okay. Alright. Okay, that's off there. I'm going to make sure I didn't damage the pads up on top, and I didn't. So that's good. Now, let me see if I can suck that old solder up. I probably can. Let me clean the tip real good. This is an old tip. I might have to put a brand new tip on. Yeah, I might have to put a new tip on. This tip's like, I think, 15 years old. There might be a inner ground plane on this. Yeah, it's not sucking that out. That's not good. That came out. Now this is one of the, okay, another thing I wanted to say. Okay, let me get, yeah, I can tell this is going to be a pain in the ass working on this board. I can already tell that. Yeah, it's going to be a pain in the ass. Let me get my tweezers. Is it going to be these ones? Let me see. Yeah, I can already tell it's going to be a pain in the ass work on this board. Yeah, I can already tell it's going to be a pain in the ass work on this one. Okay, so I got that lead out. That's good. Got that lead out. So let's see if I can suck the solder out. Yeah, that solder's out. It's out of there. Okay. Now, normally, I rarely ever have to use solder wick. Okay? That's another thing that I see a lot of you use all the time is solder wick, solder wick, solder wick. No, don't use solder wick. Solder wick is the only time you use solder wick is when you can't seem to get the the solder out of the holes with the normal solder pump or desoldering pump. Then you try the soldering wick. Okay? So, but in general, try not to use solder wick. Okay. All right, let's try this again. I could probably leave that hole just soldered with solder filled, right? Because I'm only going to use one of the holes. Remember? One of the negative holes. So, yeah, that's what I think I'll do. That's what I think I'll do. I'll just use, I don't need, as long as I have the other hole, the other negative hole clear, should be fine. Now, what I like to use for cleaning up stuff like that is a cotton makeup pad like that. And then I take my alcohol right here. I don't use a spritzer like you dumbasses do. No, that's not the way you do it. And then this does a much better job cleaning this. Much better job. Okay? And do the same thing. Flip it over like that. Make sure it's ain't the camera. And same thing on this side. Clean that board really good. And I'll zoom in and show you what it looks like. Okay? Here's the stuff that came off that board, right? Okay. And then we're going to zoom in, show you what that board looks like in that area that I just did. And that's what it should look like when you're doing it. Okay. There you go. See how that looks? See how nice that looks? That's how it should look. Yeah. That's how it should look. Just like that. That's ready for soldering on the new capacitor. Alright, now where are we at here? Let me move my iron out of the way so I can get to that one. Here, where's that? Is it right there? Where the fuck is it? Where the hell is it? There it is. But look how clean that board is. And what you could do, what I use sometimes, I use a soft makeup brush. Where the hell is the camera at? God, this is... Okay, I'll show you. But anyway. Brush off any stuff that might be on the board. But you can see how it looks. It looks really good. Turned out really good. See? The one that's filled up, the one hole is filled up, I'll just leave it because I'm only going to use 2 of the holes. The center one, the center hole, which is what? That one there, that's your positive. Right there. And the 2 outer ones, that's your negative. And to make sure of that, okay, let me zoom back out. Yeah, let's zoom back out. Okay, and the brush that I use a soft makeup brush like this. It's one of the tools I use, real soft. And it doesn't generate static electricity. Not that I know, I've never had any problem with that. And it's real soft for, you know, it's perfect for brushing off your board, you know. It's perfect for that. But yeah, I'm showing you the tools that I use. Okay, I want to make sure, I want to double check, because I don't want to tell you guys wrong. Alright, I don't want to tell you guys wrong. I want to make sure that that center, that is the positive. Pretty sure it is. That it is the positive. Okay. Let me see something here. Yeah, because, okay. Let me zoom back in again. This is important. I'm trying to show you guys this. This is important. So I hope you appreciate me taking the time to show you this stuff. Because I don't want you guys that have, you know, to damage your IBM PC motherboard. I don't want you to damage it. So I'm making sure I show you the correct way. Tell you some good, useful information. But as you can see, just find out what pin this is. I believe that's your 12-volt line from your power connector, right? And it goes, and you just trace it, and it goes all the way back to the center part right here. So that would be your positive right there. That's your positive. Yeah. And then these 2 on the outside are your negative. Okay? So let's zoom back out, because I got to solder in the new part. I want you guys to see how I do it. Okay? There we go. Alright, so we're going to put on the new part. Alright. Now on that one, that's on the 12-volt rail. So I'm going to use a 25... Okay, 10 microfarad, 25 volts. But you know what? I think I might go back with what they said in the schematic, which is 16 volt. I might just do that. Yeah, 16 volt. Yeah, 10 microfarad, 16 volt. And now on electrolytic capacitors, the stripe is negative. On tantalum capacitors, the stripe is positive. Remember that. Okay, so there's that cap. You don't want to push it down too far unless the spacing is correct, like the pitch, the lead pitch. So let me make sure it's not spreading out or damaging the capacitor. I don't think it is. Appears to be fine. So, okay. Just want to make sure I'm putting in the correct polarity. Right? Okay. Alright. Okay. And then we're going to solder that bitch underneath the camera? Yeah, I'm underneath the camera. Okay, so bring my iron a little bit closer. I'm going to need my solder right there. And my iron. And then, yeah. Okay. So, I'm just going to spot solder it for now, just to make sure that it's straight. Okay. And where it needs to be, and that the polarity is correct. So negative will be on the outside hole. Okay, that looks pretty good. These are high quality Sprague capacitors. So I shouldn't have to worry about replacing these. Well, I'll be dead but before these need to be replaced, because I probably only got about another 30 years to live. So I won't have to worry about replacing these in my lifetime. When my daughter gets my computers, she'll have to worry about it. And you notice I'm not using any flux. You notice that, people? No flux at all. Okay, that looks pretty good. And let me check the other side. Yeah, the solder did go through on the other side because it's through a whole part. So that looks good. Let me clip the leads. Now when you clip the leads, you want to clip, do not cut into the solder. You want to cut just above the solder connection. I'll zoom in when I'm done to show you. Just above the solder connection. You want to actually have a nipple above that solder. Okay? Now let me clean it with a cotton. Now something like that, you can clean with a cotton swab. No problem. You know, something like that. Small part like area like that. Now don't have it sopping wet. That's another thing that you guys get wrong. You want to take your cotton swab and between two fingers and, you know, squeeze out some of that excess alcohol. Okay. There you go. That's looking good. Okay. And now I'm going to take my brush. Remember my brush? See? Just make sure there's nothing on there. So that looks good. Okay, put that there. Yeah, that looks really good. So that's the first cap. They got 10 more to go. No, I'm not going to do those online because it'll take too long. The video will be way too long. But I did want to show you how to do at least one of them. That's the one on the 12-volt line. And I'm going to zoom in so you can see it really well. And yeah, you'll be able to see it really well. So don't need the camera. We'll zoom in. And I believe it's, where is it at? Where the fuck is it at? Oh, it's right there. Oh, it's right there, man. Okay. Yeah. Well, put it like that. Okay. Yeah. It's right. Where is it? Let me take my glasses. Sometimes I see better without my glasses on. Well, I did such a fine job. There it is right there, people. Right there. That's how it should look. Just like that. And if you notice, if I go up like this, you'll be able to see that there's a small nipple above the solder. Okay, you don't want to ever cut into the solder. You want to have a small nipple above the solder, just like that. Just a small amount of lead above the solder. And if you look at it like this, look how nice that turned out, how nice and straight it is. Just how nice that is. See, that's the way you want to do your work. That's the way you want to, that's the way you want to do it, people. Just like that. That's the way you want to do it. Okay? That's the way you want to do it. Just like that. You notice the negatives on the outside, and your positive is on the inside. All right? So put it down like this, and there you go. Yep, there you go. Now I got 10 more I got to do, and then this motherboard will be recapped, and I can put it back into my installation. But I want to show you how to do it. I mean, how I recap capacitors, how I remove the old ones and solder in the new ones. Sometimes, like on a 3-leg cap, just cut one of the outer legs and just treat it like a 2-leg capacitor. Just walk it out, heat one leg at a time, walk it out a little bit at a time, you know, and then there's no leads left in the holes, right? So then it's a lot easier to use your hand desoldering pump and just suck out the solder or whatever, or use solder wick to get the solder out. Sometimes you do have to use solder wick, but most of the time, in general, in the electronics industry, we rarely ever use solder wick. Believe it or not, we mainly use that hand desoldering pump. Oh yeah, we only use the solder wick when we had to, for stubborn areas where the desoldering pump just won't work. You know, sometimes, you know, just add a little bit of solder and just use a solder wick, and yeah. But the reason why you don't want to always use a solder wick, or use a solder wick in general, is because you have to apply too much heat. And when you are soldering these boards, especially old vintage boards like this, right, you want to, you don't want to apply too much heat. In fact, another thing I noticed that you guys are doing wrong in your videos is you're holding the iron too long on the part. In general, you should never have to have the iron on the part, on the lead, for more than 4 seconds. In fact, in the electronics industry, we were so good, in fact, I'm so good, I could solder a part within 2 seconds. 2 seconds. From the time I put the iron on her and put the solder on her, 2 seconds, and it's done. Never more than 4 seconds. In fact, if you worked in the electronics industry, if the supervisor or the line coordinator ever caught you spending more than 4 seconds on a solder joint, she'd warn you the first time. She'd write you up the second time, or like me, write you up the second time. Third time if you're caught, you're fired. That's right, because you can burn up the pads, you can burn up the boards, and even the parts. The parts can get hot. Especially if you're hand soldering, you know, parts like ICs. These are soldered on. Of course, these probably went through the flow solder machine, but a lot of times we have the hand solder on ICs too, and transistors. And so on chips like that, or parts like that, you never want to have your soldering iron on each lead for more than 4 seconds. In fact, it's preferred to have it on, like, keep it down to like between 2 and 3 seconds. Oh yeah. Oh yeah. Anyway, that's it for this video. Now I'm going to have fun soldering on, you know, or removing the other 10 capacitors and soldering on 10 new ones. But I want to show you how I did the first one, the 12-volt one here. Show you how I did it, you know. And it's okay to replace the tantalum caps with normal electrolytic. Just use high-quality electrolytic capacitors. They're usually made in Japan, or Germany, or England, or the United States. You use good quality capacitors. And don't get them from China. Like if you're getting them off eBay, one of the things you want to tag, you want to check, is US only. Okay? Do not buy electronics parts from China. There's too many knockoff parts, low quality crap. Or get your parts from a reputable electronics parts dealer here in the United States, like Mauser, but keep in mind they're going to be more expensive than, you know, buying them on eBay. So yeah, if you buy from a U.S. seller on eBay, you should be okay. You should be fine, you know. But yeah. Anyway, this video is probably too long now, but that's okay. This is an important video. that's it for this video. Stay tuned for more of my IBM PC refurbishment videos, because I'm going to show you how to recap the power supply. And I'll probably do probably 2 videos on the power supply. You know, it's probably going to take 2 videos, just like it did on the Amiga 2000 power supply. It's probably going to take 2 videos because the IBM PC power supply is very similar, especially the one for the AT. It's very similar to the to the Amiga 2000's power supply. So yeah, it's probably going to take 2 videos on that. I'm also going to show you how to properly clean the disk drives and service the disk drives on these old IBM computers. Stay tuned for that. And yeah, anyway, that's it for this video. My name is Hans George Campbell, and until next time.